Hello, my biologists. Just wanted to let you know in Unit 4, we're going to try something a tad bit different. Seeing as so many people are quarantined because of exposure or out for different reasons, I'm going to give all your notes via video, okay? So if you're out, these are your notes. You'll be able to fill in your student notes, that regular old PDF, with Cami at home just by watching this video. If you're in class, you'll be able to watch this video individually and fill out your notes. But I'm the added resource of sitting in the room. So if you need to talk about mitosis, let's say, a little more and learn a little more, I'm sitting in the room with you. But we're going to do notes this way. Hopefully it works out pretty good, and hopefully, maybe by Unit 5, everybody will be back together. So this is part one. So go ahead and open your notes and fill in the blanks as we go through. And I recommend that the left-hand side's got a lot of extra room. So if it's something that I bring up, multiple times while we're talking about it, you may want to make your own notes. They're on the side of your notes handout. Of course, the notes handout is yours. You do not have to submit it back to me. It is yours to use for all of the different assignments, especially on our end of unit exam. So anyway, this Unit 4 is based on a process called mitosis and cell growth and division, if you want to think of it that way. Our cells often divide and grow. Okay, think about the size you were when you were born. Right, newborn baby boy or girl, you're sitting there. You're obviously not the same size now as you were then. So what happened? Well, you grew up, of course. But on a cellular level, your cells had to make more of themselves, okay? So we had to make more and more of each cell. That's how we grew. We got bigger because our cells were able to make more of themselves. They didn't just magically come together and fuse to make more. They really didn't just bud another one off of themselves. There's a special process called mitosis, and we're going to get there. Okay, Unit 2 or Section 2 will cover all of that. Also, think about when you get injured. Let's say you cut your finger. Ouch. You cut your finger. How does your body heal itself? How does it get back to a normal sense of self? How does it repair those underlying tissues? How does it repair, if it went deep enough, the bone that may have gotten injured? How does your skin on the surface repair itself? It's through mitosis. So there's this overarching thing called the cell cycle. Okay, this is the process that a cell will go through in its lifespan over and over and over again to make more of itself. All right, it'll also carry on normal life function during that, but we're really going to hit up and focus on that division where it divides into two cells. All right, there's 4 main stages of the cell cycle. That's the biggest thing to look at. And this is a regular pattern of growth. So the cell does get bigger. It grows. It also replicates its DNA. So it makes copies of its DNA. We'll learn more and more about DNA as we study the next 2 or maybe 3 units. Okay, so we'll get into that. But DNA is simply genetic matter, the genetic material that makes an organism that organism. And then also a part of the cell cycle is this cell division that takes place in eukaryotic cells. Remember, eukaryotes are those that have nuclei. So originally, if we look back at the past, I like history. Originally, the cell cycle was divided into 2 stages. And that was simply because the microscopes at the time, they couldn't see exactly all the minor steps that were going on. We called one phase interphase. And this is where the cell kind of didn't do anything. It was just kind of growing, doing normal activity. And then we had the second phase called mitosis. And mitosis is where the cell, divided into 2 of them. All right, but thankfully, we had improved techniques, improved tools like better microscopes that later allowed us to identify 4 distinct stages of the cell cycle. The first stage, and I love this little chart right here. This is a great little chart to put to memory. I believe your notes has that also written in it. We can see the 2 main stages. The old ones, interphase is this big line that shows you all these things. In here is interphase, and then we have mitosis, which also has something called cytokinesis. We'll learn more about that. So anyway, gap 1, or abbreviated G1, this is where the cell carries out its normal functions. Okay, Everything just is normal in there. It grows, it increases in physical size. Also, it increases the number of organelles. So, if it's a muscle cell, it's making more and more and more mitochondria to make more and more cellular respiration occur so the muscles can do their job. All right, so everything's getting bigger in gap 1. Everything's carrying on normal growth and, excuse me, just like a complete organism of a human would grow up. Everything, they get bigger. They become more intricate. Gap 1 is where the cell on that small level does the same thing. There's another stage called synthesis, or abbreviated as an S, and the cell will make a copy of its nuclear DNA. So its genetic material that's found inside the nucleus makes a copy of itself. All right? So you see what synthesis means there. By the end of that stage, cell nucleus contains 2 complete sets of DNA. All right? They're exactly the same. They're not making some crazy new copy of DNA with mutations or anything like that. It's an identical copy. All right, got it? So S phase or synthesis makes a copy. G2 or gap 2, it's still got 2 copies of DNA, remember. The cells continue to carry out normal function. There's typically additional growth, so the cell does get bigger, and that's just kind of making way for it to divide later on. And this is also a critical checkpoint. Think about a checkpoint. If you've ever had to go through a checkpoint, like if police officers set up a checkpoint, every car has to come through and stop. Might have to give your driver's license, all this good stuff. If everything looks good, what does it do? You just continue on, right? You move forward. You keep going down the road. If something's wrong, they'll typically pull you off the side or tell you to turn around or arrest you because you're a horrible person. All this type of stuff. Think about that. This is a checkpoint where if everything's going right with the cell, it's made a DNA copy of itself during synthesis. The cell's at an adequate size. Nothing is wrong with its DNA. It will move forward. If something's wrong at this stage, oftentimes that cell will die, right? We learned about lysosomes and how they're like suicide sacs. At this point, a lysosome would pop open and enzymes would begin to devour the cell in itself because that cell does not want it to be copied. Okay, the organism at large does not need that cell copying itself if something is wrong. And then we have mitosis. Mitosis, and you can see there's lots of little steps in mitosis. That's what we'll cover in section 2. But this is the division of the cell nucleus and then all of its contents. All right, so that's what we're really going to be focusing on. Remember, at this point, thanks to synthesis that happens during interphase, we've got 2 copies of DNA. All right, so when mitosis occurs, it's able to split those 2 copies and turn one nucleus into 2 of them. We'll look at this in depth. There's several different steps, as you can see, that prophase, metaphase, anaphase, telophase that happens in there. After the nucleus splits into 2 identical nuclei, then something called cytokinesis occurs. This is included in the mitosis process. It's kind of an add-on, if you will, but most people just kind of lump it together. And this is where the cytoplasm, everything else inside that cell, but outside of the nuclear membrane, splits off into 2 identical copies of itself. Okay, we can call these daughter cells that they're produced. So, think about this. These cells divide at different rates according to the specialization of that cell. Of course, it could be a lot. Humans have a lot of different cell types than, say, an oak tree. Okay, they have lots of different cell types, not just parts of a cell. So the rates of cell division vary greatly, very widely. Prokaryotes, remember those that don't have nuclei, they typically divide much faster. Of course, because they're not nearly as intricate. And then even the eukaryotic cells, they divide vary at different amounts according to the body's need. Look at this chart. Skin cell, we're constantly losing skin cells. We're constantly rubbing our arm against something and flaking off skin cells. If you're playing football and you get tackled and your legs get scratched all up or something, those skin cells need to be replaced. They last about 2 weeks on average. Some of them are gone much quicker than that. So your body, in order to keep up with this demand of needing new skin cells every 2 weeks, those need to divide very rapidly compared to some of these other ones. Red blood cells, about 4 months. A liver cell, somewhere between a year to a year and 3/4. Right about that. Intestinal cells, 4 to 5 days. And then look at the or intestinal lining, excuse me. And look at the intestine itself, about 16 years. So think about how long it's stuck in interphase before it starts to go through mitosis, right? All right, compared to a skin cell. So I wanted you to see different rates according to the functions of those cells and often how they can be injured. So how long does this whole process going to take? How long is the cell cycle? In human cells, at least, the synthesis phase, G2, GAP2, and mitosis takes about 12 hours. So every 12 hours on some cells will make another copy of itself. The difference lies in that G1. Remember, G1 or GAP1 is where the cell is doing normal growth, doing normal activities. That's where it differs for a lot of them. That's where we see this difference in the intestinal tissue itself being 16 years and the skin cell being 2 weeks, or the intestinal lining, which of course is getting constantly rubbed off with waste products and food products that's passing through there. As it hits that intestinal line, it's taking some of those cells with us. So it's got a very short lifespan. That mitosis, this whole cell cycle needs to be much shorter for these cells than, say, the lining. They're going to sit in gap 1 and do normal function for years and years and years, unless there's an injury. And of course, well, not of course, but rate of cellular division is greater in embryos and children. Children are constantly growing, right? They're constantly changing. They are getting bigger. They need more cells in order to continue this growth. As their bones grow, these osteocytes or these bone cells need to be made at a greater rate than mine and yours, all right? So it's going to be a lot quicker with them. There is a next section in your notes. I want you to skip through that section and just down to the part where it says number 2, mitosis and cytokinesis. It'll look like something like that. If you're looking for what that looks like, this is your notes. This is what you've been looking at. Is of course our chart. Love this thing. Know that thing. There's a little chart for you. This is what I'm talking about. So if you wanted to come in and put a big old fat X right here or block it out with a black square or something like that, you don't need this information from me, okay? This chart as well, boom, bloom. We're not going to worry too much about that. We're going to cut some of the stuff that may not be super necessary for us. And so this is where we'll pick up section 2. You're welcome to watch this video as many times as you want. I would certainly make it a point to come up here in your notes and don't turn them into me, but save them just like last time. So if you're in class and you don't remember how to do that, ask me. If you're at home and you don't remember how to do that, email me and ask me, and I'll be happy to tell you, okay? We'll pick up at another video for section 2, and this will be where we start over in our notes, okay?